Hello everyone. I am glad to welcome you to another lesson dedicated to working in 3DScan. In this tutorial, we will look at the procedure for classifying as well as reducing a point cloud. Such a situation arises when it is necessary to recode points from the unassigned class to the corresponding vegetation and ground classes. Let's move on to a specific example. Import the point cloud. The import window opened. Specify that the initial cloud is in units of measurement, meters, and the imported cloud will also be transferred to the program in meters. Leave the other settings unchanged and click OK. Use the View Mode command in the Settings group. In the Coloring field, set the parameter to Code and see that the point cloud is not assigned a class. Go to the 3DScan tab and use the Ground command in the Classification group. In the Parameters, the Source Classes field lists the existing classes of the cloud that will be involved in ground classification. In the Ground Class field, specify the target class that should be assigned to the recognized ground points. The Cell Size parameter allows you to set the side length of the square cells into which the area occupied by the point cloud will be divided in the plan. The smaller the value, the more accurately the terrain elements will be reflected. The parameter value must be greater than 0. Let's set a value of 7.5 in this field. The maximum window size parameter allows you to set the size of man-made objects that do not belong to the ground. Buildings, cars, etc. Objects of the specified size will be excluded from the classification. The parameter value must be greater than the cell size value. Let's leave the default value in this field. The terrain angle and iteration angle parameters allow you to set the maximum terrain slope angle in degrees and the maximum deviation angle of local irregularities from the main direction of the ground surface. Let's leave these settings as default. The maximum distance parameter allows you to set the maximum distance above the ground surface, above which points will not participate in the classification process, and therefore will not be classified as ground points. Let's also leave it as the default. The Save Ground Model parameter allows you to automatically build its triangulated model as a mesh objects. Leave the value as No in this field. The Classify Vegetation parameter allows for the classification of vegetation. When setting this parameter to No, some fields in the panel will disappear. In our case, we will set it to Yes, so additional fields will appear that need to be filled out. For vegetation classification, you need to specify two parameters, class and height. In the class field, specify the target class for classifying points of low, medium, or high vegetation. In the height field, specify the height level for low, medium, or high vegetation in drawing units. Let's leave the class and height fields for all types of vegetation as default and apply the set parameters. Now use the View Mode command and change the value in the Coloring field to Code. As we can see, our field is colored according to the coding. All layers are clearly visible: ground, low, medium, and high vegetation. Using Layer Properties, or Layer Manager, we can control the visibility of points. Let's go to the Layers dialog box, and for the experiment, disable all layers except the ground. As we can see, the vegetation points are not represented in the drawing. Let's turn them back on. Also, one of the handy features is the Verification of the Earth command, which allows us to view the results of Earth classification in a convenient way. We can find it in the 3DScan tab in the Classification group. Let's activate it. We see that the points of the ground are displayed as a triangulation network. For more convenient display, let's change the display style to shaded. On the left side, we can see the settings of this command. For example, let's change the value of the Synchronize Views field. After that, both our screens will be rotated similarly. We can always explore our classified ground in more detail and view specific ground points. Let's also change the display style back to shaded with edges. We can see that our land is now a frequent irregular triangulation network due to the excessive number of point clouds. Let's cancel the command by closing the panel on the left. Let's look at an interesting command, reducing the point cloud. This command allows you to reduce the number of points in the selected cloud. Processing time for large, dense clouds can be unacceptably long. The command allows you to eliminate the excessive density of the point cloud to thin the cloud. Activate the command. Notice the settings panel on the left. The cell size field is responsible for reducing the number of points in the cloud by averaging the coordinates and attributes in cubic cells of the specified size. The larger the cell size, the fewer points will remain in the cloud, and the faster its further processing will be. The Classes field reflects the classes within which thinning will be performed. Enter a value of 5 in the cell size field and look at the result. As we can see, reducing occurred, and the number of points in the cloud decreased. Now activate the Verification of the Earth command again. And we will see that our network has become extremely rare due to the small number of points. This concludes our lesson. Thank you for your attention. See you in the next lessons.